a little bit new. It looks frightening here, but with your great powers of observation, I should be able to do this. Now, for Mitchell here, he was having difficulties, if you don't mind me telling the class, with long division. So I'm going to factor this with long division right now so that we feel good here, okay? So I have to factor the denominator. Did anyone able to find a factor that works for this? Go ahead. 1 works out quite nicely, okay? So f of 1 equals 0. Okay, so similar than Peter, what is the factor then? Was there a book left here? Yes. Is it here? Okay, so we said then therefore x minus 1 is a factor. Now you can do this with synthetic and I have no issue with that. I'm going to do it with long because this will be on the test. So it says x minus 1 into. Using long division or synthetic, how do I write the next row inside the divider sign? Yes?
3x cubed plus x squared plus x minus 1.
Right, not 3x cubed, just x cubed, but yes.
Oh, yeah, sorry. 3x squared.
So what I did there, right, I had to put the 0x squared because there's no x's here, right? So I just had to put that in there. So then what you're thinking is how many times does x go into x cubed? So x times what gives you x cubed? Go ahead, Foxman. X squared. So what I'm going to do is I'm going to line up right above the x squares, put an x squared just like that. Okay? Then what I'm going to do is I'm going to FOIL through and I'm going to say, well, x times x squared is x cubed. Okay, and then negative 1 times x squared is negative x squared. Okay, so it just balances. Now what I'm going to do, of course, if you remember, think back, you just subtract them out. Okay, guys, can't sit together if you want to yak to a little lesson, please. I'm not kidding, okay?
Did you say yak?
Yes, hey, come on, yes, I said yak. Isn't yakking when two old ladies talk? The yak is not
I
that
got a party there. Yeah.
All right, so I'm going to subtract these through here. I'm going to say x cubed minus x cubed is nothing. Then 3x cubed minus negative x cubed should hopefully give us 4. Okay. All right, can someone remind me from the last test, what do you do next? What comes down? Go ahead, Tom.
0 comes down.
0 comes down. So I'm just going to do that in red here. So it's going to be plus 0x. Then what you're thinking is how many times does x go into 4x squared? How many times does x go into 4x squared? Okay, good? Sort of, but also it's 4 actually, because it's going to be 4x, right? It's because you want, right, when they multiply that to be the same thing. So it's going to be 4x squared and minus 4x. I'm going to subtract those out, and you're left with 4x now. All right, then I'm going to bring this down again. And up with negative 4, that's going to be, what is that, plus 4? So it's going to be minus bracket 4x minus 4 and 0 remainder. Since there's 0 remainder, what does that tell me? It's actually factorable, right? Okay. So therefore, this equation is really f of x equals 3 over x minus 1, x squared plus 4x plus 4. Now, how do I factor x squared plus 4x plus 4 from last year? Go ahead.
X minus 2 and x minus 2.
I think it's x plus. I think it's x plus, though. I think it's x plus. So x plus.
Yeah.
Okay, x plus. So we're going to say then f of x equals 3 over x minus 1, x plus 2, and x plus 2. Okay, hopefully we're sort of okay with that so far. Okay, so I was just M&A factoring for that. All right, now from Friday, for those that were here, what are my asymptotes on this graph now going to be? Yeah, Tristan, go ahead.
Maybe 1 and negative 2.
Okay, so my asymptotes. You say x cannot equal 1 and negative 2. Right. Awesome, very good, thank you. Y cannot equal. Okay, now, are we feeling sort of okay with what happened on the left-hand board there? Okay, good. Now I'm going to show you the interval chart because that's the only part that's scary, okay? Because this is the same sort of thing we did for greater than less than in the last test. Okay, but we're going to do it for after this. Okay, sort of okay? A little bit, mostly. All right. So what you're going to list here, if I, and then we're going to do this, we'll extend page here, I think. Mitchell, can I get rid of that? Do you have, you do that? Okay. So I'm going to just extend that a little bit, and I'm going to make my interval chart. I'm going to say f of x. Now, Foxton, do you mind if I embarrass you in front of the class?
You can try.
Okay. Foxton came in at lunch and he said the difficulty that he was having with these questions was he didn't know what to put under the f of x column. Right? So he said he didn't know what to put right under here. Other than that, he said he felt good with the interval chart and all that. What goes underneath the f of x here, Owen?
Whatever you have in your brackets.
Whatever you have in the bracket. Well, not only that, also this here too. So anything in the numerator or denominator goes under f of x. So I'm going to put a 3 here. I'm going to put an x minus 1. I'm going to put an x plus 2. And you can either put a squared or write it twice. Either one. And then we're going to have an overall and test point. Okay. Now for Fox and everyone else, is that clear where all those magical numbers came from? Sorry, I'm very short on Fox. Peter, go ahead.
What effect does that 3 have inside?
In this case it doesn't. In this case it doesn't. But remember when there was a negative before, you could switch the sign of the entire graph. Or in today's lesson, instead of having a 3, I'm going to have an x plus 3 in the numerator. So it's just a habit of getting into listing it in there. Okay. Now, sorry, yeah, go ahead.
Are you gonna ask us to factor out the x plus 3? Like, are you gonna ask, like,
No.
factor out?
No. You'll have to factor it, right, but it's not going to cancel, right? You'll factor it, but there'll be like a variable in the numerator and a variable in the denominator today. That's going to be the difference. Right? Yeah.
I was wondering, where'd you get the y also?
Always, it can't be 0. Okay, for right now, from last year. Because if you're thinking, what that means is this entire fraction, in order to be 0, the numerator would have to have a variable in it. Right? Like 3 can never equal 0, right? It can be very close, right? But it can't exactly hit. All right, so can someone be brave now and tell me my intervals? What's the intervals? What's the first interval going to be? Oh, goodness me. All that homework I gave during the Blue Jays game, and no one's going to raise their hand like they did. Brian, go ahead. Yeah, less than -2. Okay. Now, what that -2 is, that was one of the asymptotes there. Okay, so it's going to be less than -2. Go ahead, go on.
X is larger than -2, but it's smaller than 1.
Good, so -2 is less than x is less than 1. And then finally, x is greater than 1. Now, so what this is between every single asymptote, right, there's going to be a break there. Okay. So now I'm going to pick my favorite numbers. You can pick your own favorite numbers. My favorite number less than -2 is going to be -7. My favorite number between -2 and 1 is going to be 0. And my favorite number greater than 1 is going to be 1.00001. Okay, it doesn't have to be for you. Okay, you can pick 1,000. Okay, but that's my favorite number greater than 1. So what I'm going to do is now I'm just going to start subbing in the numbers here and see what happens. All right. So I'm going to say if I sub in -7 into 3, that's going to be a positive. Okay, if I sub in a 0 to 3, that's going to be positive. Looks like Nick's not coming back. If I sub in 1.001 into 3, that's going to be positive. Nothing's going to happen. Okay. For x -1, -7 minus 1 is a negative. -7 plus 2 is a negative and a negative. You have to include that x plus 2 twice because it's squared. All right, so that works out. So what's a negative times a positive times a negative times a negative? I think that's a minus, right? All right. All right, so 0. 0 minus 1 is a negative. 0 plus 2 is a positive and a positive. A positive times a negative times a positive times a positive is what? Negative. Ooh. Don't they always alternate, Mr. Sadler? No, they do not in grade 12. Okay, so you have to do the chart. Right, that's a double root. Okay. And finally, 1.001 minus 1 is going to be a very small plus and plus and plus. So it's a big plus. Okay. I'm going to graph this for you right now, and then we'll continue on today's lesson. How you feeling? All right? Good? You look happy. I'm sorry about your problems. One people, you're in my class next year. I was going to say one be greater than the teacher that doesn't love you, but you will. Okay, let's graph this here quickly. So this is going to be a rough sketch for right now. Okay, because I want to actually do my lesson today. So I'm going to do there's 1. There's 0, -1, -2. The textbooks into y-intercepts, I'm not really into them. but if you want to do a y-intercept, you can. I'm not really crazy with them though. So you're going to draw your asymptote as a dotted line like this. That says x cannot equal -2. X cannot equal 1 and a asymptote for a horizontal asymptote right here. At y cannot equal 0. All right, things are looking good. No, but I agree. 1, 2. Go ahead.
Would there be a way to like tell if it's positive or negative without using the interval chart?
No. Well,
Like we couldn't tell from end behavior or something?
you could do some end behavior, but you need to do end behavior and test points all the way through. The interval chart just sets up your test points. We are going to do end behavior in this class, so that in today's lesson again for how that's going to work. But still, it's very difficult to know just from looking at the equation that's going to go plus minus 1. There's going to be some sort of test points in there to see how it's going to go. For the traditional ones like you learned last year, that were just sort of hanging like this, no big deal, right? But this is a little bit more complicated. Yes.
So the x plus 2 squared has no effect on the asymptote, it's just still a straight line.
It's like a double asymptote, okay? So what, let me just show you a color. I don't want to scare you guys. A negative graph's going to look like this. Now what the x minus 2 squared is going to do is that, remember how before the graphs went bottom, above, and they all change like that? There isn't technically an above one, but you can't see it because it's a -2 and -2. So this now is going to go beneath again. And this here is going to go above.
So there is technically a positive one between -2 and -2.
Where there isn't one. You know, there's no real one there, but that's where it would go, right? So that's what the double asymptote does. It makes it so that there's two negatives consecutively there.
And it's like an uneven one.
Right on. A triple one again would also be again. Now I want you to put this out of your mind, not put this out of your mind, right? But rules like that, like that's like grade 11, so we're moving past that today, okay? Like remember that's like day 1, we're moving past that and what we're doing today. Are we feeling sort of okay about this before I continue? Yeah, Foxton.
Can you just like one more time say how you got those red lines?
Yeah, no problem. We use these lines here or these lines here, like the curves or the
curve one.
Okay, so all I'm saying is if the, I know we did this with the table of values on Friday, what we're saying is if something's negative, okay, if you're doing like -50, the answer is going to be like almost 0. It's like 0 minus, remember we talked about that, so -0.00000. As you get closer and closer and closer to this, we're going to get down to infinity, down to negative infinity. So you're going from negative infinity up like this into here. It's going to go negative infinity down here at this line, and negative infinity at this line, but it's going to come up and meet somewhere in the middle there. We don't know how high this is going to be.
Okay.
And the same thing here. Basically, the lines hug the asymptotes. That's what you got to think, okay? They pretty much are going to slide right along there. Yeah.
Do you know why they're two different?
I think so. I
Because
think
like
I
when
got it.
x is like across.
I'm going to pause the video, and then we're going to talk about one quick thing.
Yeah, those draws.
Yeah, like, and when it's between those two points, between -2 and 1,